Okay, annuities. What is annuity? Okay, annuity is a sequence of equal payments made at equal periods of time. Okay, so when you pay money, say monthly or yearly, you pay the same amount monthly or yearly. That is called an annuity account. You're making an annuity account. Okay, so if the payments are made at the end of the time period, okay, if you make the payments at the end of the time period, say if you're paying monthly, then if you make the payment at the end of every month, or at the end of every quarter, or at the end of every year, okay, then it is known as an ordinary annuity. Okay, if payments are made at the end of the time period, it is known as an ordinary annuity. But if the frequency of the payments, okay, if the frequency of the payment is the same as the frequency of compounding, then this is known as annuity certain. Okay, so if we have both of these together, if payments are made at the end of the time period, and if the frequency of payments is the same as the frequency of compounding, then this is known as ordinary annuity certain. Okay, so ordinary annuity certain means all payments are made at the end of time period, and the frequency of payment is the same as the frequency of compounding. Okay, so the time between payments is the payment period. Okay, and the time from the beginning of the first payment to the end of the last payment is called the term of annuity. Okay, the future value of the annuity, or the final sum on deposit, is defined as the sum of the compound amounts of all the payments compounded to the end of the term. Okay, the formula for future value of annuity, we have already looked into this in our last lecture. Okay, we have learned how to derive the formula for the future value of annuity using compound interest formulas and geometric progression. Okay, so if you have forgotten, you can always revisit the lesson and you can look through again how to derive this formula. Okay, so just to remind you again, the future value of the annuity, okay, is as, this is the formula for it, as is equals to R into 1 plus I to the power of N minus 1 over I. Okay, this is the formula for the future value of annuity. That means after depositing money into the account every time period, you want to find out how much you have in the end. So you use this formula to calculate the future value of annuity. So we have done this already. Okay. Okay. So before I continue with today's lesson, I want to do some examples first for future values of annuity. Okay. Okay. Let's look at this question. Okay. Amira deposits 10,000 at the end of every year for 8 years in an account that pays 7% compounded annually. How much will she have in her account at the end of 8 years? And how much interest did she earn? So the first thing that we need to do is we need to determine if this is ordinary annuity or some other annuity. Okay, how do we know what kind of annuity is this? Which are the keywords here?
End of every
Can hear?
end of every year.
Okay, well, I can't hear the person. Okay, it is this word, okay, at the end of every year. So when you see the word end here, it tells you that this is an ordinary annuity. Okay, so how much will she have in her account at the end of 8 years? means we want to find the future value. We want to find the future value. Future value is represented as S, or we can even use FV, future value. Okay. So what do we know? What is given here? 10,000 is what? 10, okay, this is our formula. Okay, S is equals to R into 1 plus I, the power N minus 1 over I. Okay, what is given here? 10,000 is our R. Okay, R means our our yearly installment is 10,000. Okay, so we know that N is every year for 8 years. N, you know, is MT. M is the number of times it is compounded a year. Here, the number of times compounded is 1 times by number of years is 8. So your N is 8. Okay. I is interest rate 7% divided by M, because M is 1, so I is 7%, which is 0.07. Okay, 7%. So we have all this information. We can substitute into our formula. So we have 10,000 into 1 plus 0.047 to the power of 8 minus 1 over 0.07. Okay, so we have, okay, so how much will she have in her account at the end of 8 years? She will have in her account 102,598 ringgit and 03 cent. Okay, and how much interest did she earn? So now to calculate how much interest she earned, we need to know first how much of money did she deposit into her account. Okay, so how much interest did she earn? Okay, so how much did she put in? She deposited, okay, her deposit 10,000 per year multiplied by 8 years. Therefore, she deposited 80,000 ringgit into her account. But at the end of the time period, she got 102,598 ringgit and 3 cent. Okay, so how much did she earn? Okay, so the interest that she earned is, we minus the amount, minus 80,000. So this will give us 22,598 ringgit and 3 cents. Okay. Okay, so this is an example for ordinary annuity. Okay, calculating the future value of an ordinary annuity, which we did in our last class. Okay, so we're just revising it here. Okay, so let's continue with the question. Okay, supposing Amira had deposited 833 ringgit and 33 cent. Okay, in this question, she deposited 10,000 at the end of every year. We know that 1 year is 12 months. If she wants to deposit monthly, so 10,000 divided by 12 will give us 833 ringgit and 33 cent. So if she deposited this amount at the end of each month for the same number of years for the same interest rate, how much will she have at the end of 8 years? Okay, so now our R here is 833 ringgit and 33 cent. T is 8. What's our T now? Anyone? What is our T now?
9.
Yeah, our N, sorry. Our N is 96. 96. I will be 7% over 12. Yes, so this is 0.07 over 12. Okay, so now we have this. We put into our formula. We want to find the future value. So this is 1 plus I into N minus 1 over I. Our R is 833.33 into 1 plus I is 0.07 over 12 to the power of n minus 1 over 0.07 over 12. Okay, so using our calculators, we can calculate it and we get this amount. Okay. Okay, so this is what she got. If she had paid, if she had deposited the money monthly, she gets 106,831 ringgit and 92 cent. But if she deposited it yearly, she would only get 102,598 ringgit and 3 cents. So we can clearly see that when the money is compounded more often, okay, so the final amount is much more. Okay, so this is for ordinary annuities. Just revision this part. Okay. Okay, so now we are going to go into annuities due. Okay, before we do that, we want to look at something else first. Okay, we look at ordinary. Okay, we look at this first. Annuities due. Okay, this is the other type of annuity. Okay, annuities in which payments are made at the beginning of each period are known as annuities due. Okay, so if the payment is made at the end, it is ordinary annuity. If the payment is made at the beginning of each period, then it's annuities due. Okay, the future value of an annuity due of n payments of R each at the beginning of each interest period at an interest rate of I% per period is given as, okay, this is a formula for future values of annuity due. Okay, this is 1 plus I sorry. Okay, this part of the formula is exactly the same as ordinary annuities. Okay, so for annuities due, you need to multiply with 1 plus I. Okay, how we get this formula, how we derive this formula is exactly the same method as how we derived the formula for ordinary annuities. Okay, so I'm not going to go into how we derive the formula. Okay, you won't be tested on that. You only will be tested on application. So you can go and try to derive the formula on your own. Okay. Okay. Uh, okay, there is another formula that you can use also. Okay, this is formula 1, or there's another formula that you can use for finding the future values of annuities due, and this is, it's like this. It's 1 plus I to the power of n plus 1 minus 1 over I minus R. So you have 1 minus R here. You're minusing 1 month of installment. So you can use either formula 1 or formula 2. Okay, I prefer to use formula 1. Both formulas will give you the same answer. Okay, so this is annuities due. This is to find the future values of annuities due. Okay, so okay, other than finding the future values, we also need to find the present values of an ordinary annuity. Okay, the present value P of an annuity of n periods of payments of R each at the end of each period with interest compounded at a rate of interest of I% per period is given by the formula P is equals to 1 minus, just now it was 1 plus I minus 1. Now it's 1 minus 1 plus I to the power of negative n over I. Okay, So this is the formula to find the present value. What do we mean by present value? Okay, so when you deposit in money, say every month you're depositing money into an account. So at the end of say 5 years, you have a lump sum of money, right? That is the future value of your annuity account. But if you want to know how much is that money worth today, okay, say in future you're going to get 100,000, but today how much is it? Okay, that is called the present value. So to calculate a present value, how much is the money worth today? Now we use this formula. Okay, so P is the present value, R is the number of payments per month, I is the interest rate per period, N is the number of periods. Okay, so this is the um, formula for present value of ordinary annuity. Okay, however, if you're calculating annuity due, if you're calculating the present value of annuity due, then this is the formula that you're going to use. P is equals to R into 1 minus 1 plus I minus N over I. Okay, this part of the formula is exactly the same as the present value formula for ordinary annuity. Then you add this times 1 plus I. Okay, so this is the formula to find the present value of annuity due. Okay, so P is the present value. Okay, for annuity due, we have two formulas. You can either use this formula or you can use the second formula is R plus R. Both will give you exactly the same results. Okay, you can use either one of these two formulas. Okay. Okay, let me just explain to you the difference between ordinary annuity and annuity due. Okay, so if you have a timeline like this, say you have a few months here, June, July, okay, August, and say this is September. Okay, say you want to make 4 monthly payments. You want to make 4 monthly payments. Okay, for ordinary annuity. Okay, for ordinary annuity, the first payment is at the end of the month. So you start with June. Say you want to start paying in the month of June. So the first payment is at the end of June. You pay one payment R. End of July, you pay another payment R. End of August, you pay another payment. End of September, you pay another payment. So you have made 4 monthly payments. So when you pay in the end of June, how long is this money in your account? If you pay your first payment end of June, how long will the money be in your account? You make 4 payments. End of September, you take out your money. So how long is the money in your account?
3 months.
Anybody?
3 months.
3 months, okay, correct, it's 3 months. So the second payment will be there for 2 months, and the third payment will be there for 1 month. The last payment will be there for 0 months, because as soon as you make the last payment, you're taking out all the money already. So the last payment will be there for 0 months. This is ordinary annuity. This is how we think of ordinary annuity. Yeah? But for annuity due, okay, but for annuity due, say we have the same number of months, June, July, August, and September. And we also make 4 payments. But this time, we are making the payments at the beginning of the month. Okay, 4 payments also. So for the month of June, we are paying the first payment at the beginning of June. Okay, beginning of July, second payment. Beginning of August, third payment. Beginning of September, fourth payment. End of September, we take out the money. Okay. Okay, so the first payment, how long is it in the account?
4 months.
4 months. First payment is in the account for 4 months. Okay. Second payment will be in the account for 3 months. Third payment will be in the account for 2 months. Fourth payment will be in the account for 1 month. Okay. So that is why for annuity due, when you calculate the future value, you have to minus 1 month. And when you calculate the present value, you have to add 1 month. Okay. Because when you calculate the present value means you're calculating this way, it is 1 month extra compared to ordinary annuity. Okay. This is the difference between ordinary annuity and annuity due. Annuity due, we pay at the beginning of the month. Ordinary annuity, we pay at the end of the month. That's why sometimes, for example, we go and rent a house. Okay, some landlords will ask you to pay the rent at the end of the month, but most of them will ask you to pay the rent at the beginning of the month. That's the difference, because when we give them the money, normally what landlords do is they put the money in the account and they don't touch it for until you finish, for a long time. So if you pay at the beginning of the month, so the calculation is different from when you pay at the end of the month. Okay, so that's how it is both beneficial for them. Okay, this is the difference between ordinary annuity and annuity due. Okay, so now we're going to look at some examples of calculations. Okay, let's look at this question. Okay, Ali wants to deposit 3,500 semi-annually for 4 years to buy a car. The account pays 12% interest rate per annum. The deposit is made at the beginning of each 6-month period. What is the future value of the cash flow payments? So tell me, what annuity is this? This question is about what annuity? Which annuity? Is it ordinary annuity or annuity due?
Annuity
And how do you know that?
beginning
Of each 6-month period.
Yes, good. At the beginning of each 6 months. So that is the first thing that you must do. You must determine what kind of annuity this is, what type of annuity. Now, what do you want to find? Future value or present value? Because both formulas are different, okay? So you want to find the future value of cash flow payments, okay? So you need to use the formula for annuity due future value. So the formula is S is equals to R, okay, into 1 plus I to the power of N minus 1 over I times by 1 plus I. Okay, okay, let's determine first what we have. Okay, what's already given. So do we know our R? R is
3,500.
okay, correct, 3,500. And what is our N here? Anyone? N is? How many times? We know the N is actually MT. M is the number of times compounded yearly. How many times is compounded daily? How many times is compounded yearly is?
2.
2, yes. Semi-annually, that means twice. Times by number of years is the term is 4. Therefore, our N is 8. Okay, by now you should know this because every single concept is the same calculation. Okay, even compound interest, everything, same calculation for N. Okay, interest is 12%. What's our interest here? 12% over 2, yes. So this is 0.12 over 2. Okay, so now that we have all this information, we can substitute into our formula. 3500 into 1 plus 0.12 over 2 to the power of 8 over 0.12 over 2 into 1 plus 0.12 over 2. Okay, so do the calculations in your, you can check this in your calculator later. You can check my answers lah. So you have this amount. So future value is 36,719 and 61 cents. Okay, this is how we do annuity questions. Okay, let's do one more example. Yes.
The question,
Okay.
was that 2 got a -1 in the
Oh
middle?
yeah, sorry, I forgot that. Okay, I
Thank
always
you.
do that. Okay, thank you. Hmm. Okay, let's do the second question. Two twins, John and Jane, want to contribute to their parents' retirement fund. Okay, John will deposit 500 at the end of each year for 9 years. Okay, Jane will deposit one lump sum today. How much must Jane deposit if she wants to equal the present value of John's contributions if the retirement fund earns 7.5% compounded annually? So what type of annuity is this?
Ordinary.
Why ordinary? Yes, ordinary, because it is end of each year, at the end of each year. So this is, we know this is an ordinary annuity, Okay, so we are going to use ordinary annuity formula. Which formula are we going to use? There are two formulas, right? One is for future value, one is for present value. Which formula are we going to use?
Present value.
Yes, we want to use the present value because John is going to put in 500 every year for 9 years. Okay, so Jane wants to put the same amount that John puts, but not his future value, because that will be something else that will earn interest, you see. So she wants to put how much that money will be worth today. Okay, so that means that is the present value of John's contribution. Okay, so you're going to use present value formula for ordinary annuity. Okay, so the formula is P is equals to R over 1 minus 1 plus I to the power of N over I negative N. Okay, so this is our formula. Okay, what do we know? R is 500. 500. N is 9, correct? N is 9. I will be 7.5% over 1. This is 0.075. 0.075. Okay, so substitute in the formula. We have 1 minus 1 plus 0.075 to the power of negative 9 over 0.075. Okay, this will give us 3189.44. Therefore, Jane's deposit will be 3,189 ringgit and 44 cents. Okay, so today she must pay this amount. This is what John's money is worth today. Okay, his future value will be different because he would have earned interest. Okay. Okay, let's go on to the next question. Okay. Find the future value of an annuity due, already given to you, annuity due. If payments of 200 are made at the beginning of each year. Okay. For 8 years at 5% compounded annually. So we want to find the future value of an annuity due. Okay, already given to you everything. So you need to know the formula is, we're using the first formula. Okay, we can use both formulas. So this is 1 plus I to the power of n plus 1 minus 1 over I minus r. Okay, that is one formula, or the other formula is S is equals to R into 1 plus I to the power of n minus 1 over I over I, and this is 1 plus I. Plus 1 minute. Okay, sorry everyone, it's raining here. Okay, so the electricity went out. Okay, so we can use either two formulas. So let's try the first formula first. So what is given here? We know that R is 200 and N is every year for 8 years. So compounded annually and every year for 8 years. So N is 8. I is 5% over 1. So this is 0.05. Okay, so substitute into the formula. We have 200 into 1 plus 0.05 into 8 plus 1 is 9 minus 1 over 0.05. The whole thing minus R. R is 200. Okay, so you can check the calculations. Okay, so you get 2005 ringgit and 31 cent. Or if you use the second formula, same information, substitute the information, you have n is 8 minus 1 over 0.05 in times 1 plus 0.05. Okay, and you will get the same thing. Okay, so you can use either calculation, either formula lah. Okay, this question is very clear because they told you what annuity and what you have to find. So you just have to put in the formula and substitute. Okay. Okay, let's go on to the next question. Okay. Someone pays a house rental of 1,200 per month. What is the present value of his rentals for 1 year if the interest rate is 8% per annum and payments are made at the beginning of each month? So what kind of annuity is this? Annuity due or ordinary?
Annuity due.
Annuity due. Okay. So once you've determined that, you know which formula. So now what do you want to calculate? You want to calculate the present value of his rental. So we are going to use the present value formula, which is okay, you can use either formula. So what is R? R is given, R is 1,200. And what is the N? Okay, Samad pays the house rental of 1,200 per month. Okay, that means Samad is paying monthly. What is the present value if the interest rate is 8% per annum? Interest is yearly. So what is his N here? N is 12, right?
Yes.
N is 12. Right? I will be 8% over 12, correct? Which is 0.08 over 12. So we substitute inside here. We have 1,200 over 1 minus 1 plus 0.08 over 12 to the power of negative 12 divided by 0.08 over 12 times by 1 plus 0.08 over 12. Okay, so we have, okay, so this is the present value of his rentals. If you calculate the rental, he's paying 1,200. He's actually paying 1,200 per month for 12 months. How much is this? How much is 1,200 times 12?
14,100.
Yes, correct. So this is the actual amount he's paying. Okay, but the present value today, it is worth this much. Okay, but you see, if say this he's paying this to somebody, okay, so someone actually paid 14,400, but if you calculate the future value, it will be much more. That means the landlord will be getting much more than 14,400 at the end of 1 year, and today's value of that is this much. Okay, that means someone is actually paying less, more. He's actually paying more than the value of today's value lah. That's what it means lah. Okay, let's look at one more question. Okay, a car costs 20,000 ringgit. After a down payment of 3,000, the balance will be paid off in 30 equal monthly payments with interest of 5% per year on the unpaid balance. Find the amount of each monthly installment. Okay, if you look at this, have you seen this type of question before? Have you done this kind of question before? No? You're not sure? Okay, you have, under what chapter? What topic?
Loan.
Yes, under immobilization of loans, you have done this. It's the same. So in the end, you will see the many of the formulas are the same, okay? Okay, so what are we finding here? We want to find the amount of each monthly installment. Which formula are we going to use? Are we going to use ordinary annuity or annuity due?
Ordinary.
Why?
Because we need to pay every month at the end of the month.
Okay, yes, find the amount of each monthly, but they didn't say clearly whether it's end of the month, isn't it? There's
No.
where did they say end or beginning, Okay, find the amount of each monthly installment. So in this kind of a question, they have not mentioned end or beginning. Nowhere is it mentioned, okay? So if it is not mentioned, we assume it is ordinary annuity, okay? Anytime you don't see any word there to differentiate what kind of annuity, you just use the ordinary annuity formula. So what are we going to calculate here? Which formula? Future value or present value? Okay, the car costs 20,000 ringgit. After a down payment, that means you have paid 3,000 minus 3,000. So how much do you have to pay now? Balance is 17,000. So today you must pay 17,000. So what is this 17,000? What value is this? Okay, this 17,000 you want to pay in 30 equal months. Okay, so they ask you to find the amount of each monthly installment. That means you're actually finding, what are you finding here? R, right? You want to find R. How much is the monthly installment? But what value is this? 17,000.
S.
Is it S? S means future value. Okay, the car is 20,000. You pay 3,000 already. You have 17,000 to pay. If you Today you must pay 17,000, but you don't want to pay 17,000 today. You want to pay it every month for 30 months. So what value is 17,000?
present value.
Yes, 17,000 is actually the present value. If you pay lump sum today, you must pay 17,000. But because you don't want, you want to pay monthly, so you must pay monthly installment. And all this monthly installment together will form the future value. Okay, so that means we want to use ordinary annuity formula. Okay, and we want to calculate, and we know the present value. That means we must use a formula that uses present value. Okay, so therefore we have to use the present value formula, which is P is equals to R into 1 minus 1 plus I, the power of negative n over I. Okay, so this is the present value for ordinary annuity. So our P is 17,000. Present value 17,000. N is 30 equal monthly payments. So N is 30. I is 5% over 12, which is 0.05 over 12. So substitute everything into your formula. We have 17,000. R we don't know. We want to find R. 1 plus 0.05 over 12 to the power of negative 30 divided by 0.05 over 12. Okay, so we have R is equals to 604. So this is the monthly. So at the end of the sentence, you have to write properly. Yeah. So the amount of monthly installment is 604 ringgit. Okay. Okay. Any questions so far? Okay. I think they've done all the questions. Okay. Lastly, to conclude. Okay, to conclude, present value of an annuity due is higher than the present value of an ordinary annuity. Okay, present value of an annuity due is, how do we calculate that? It's actually the present value of an ordinary annuity multiplied by 1 plus I. This is the formula for present value for annuity. Formula for future value of an annuity due is the future value of an ordinary annuity. Okay? Ordinary annuity multiplied by 1 plus I.